Today we're looking into Acme screws.
Uh-oh. Heavy machinery talk. I'm in.
Yep, and we've got this article, Why Acme Screws Are Ideal for Heavy-Duty Industrial Applications.
It's got me thinking, like, what makes those huge machines work? You know, the ones moving crazy heavy stuff.
Yeah, it's easy to overlook, but Acme screws are in a ton of industries.
Okay, so before we go too far, what exactly is an Acme screw? Like, how is it different from the screws I use at home?
Okay, so picture a normal screw, but instead of a pointy thread, it's got a trapezoidal shape. Like, think a mountain range, not just one peak. That wider base is what gives them strength.
So it's spreading the pressure out. Makes sense for heavy stuff, but does that change how it moves?
Totally. Imagine a train on tracks. It can only go forward or back, right? Acme screws are kind of like that.
Huh, okay. But the article mentions self-locking too. That's huge for safety. It means even if the power goes out, the screw won't slip under load. Think of a crane holding up a steel beam. You really don't want that screw unwinding itself.
Yikes, no kidding. So it's like a built-in safety thing, but are there times you would want it to move, even without power?
Oh, absolutely.
Yeah.
Self-locking isn't always what you want. Sometimes you need a system that disengages easily, even under load. That's where, say, ball screws come in.
Ball screws. Never heard of those. How are they different?
Similar idea, turning rotation into linear motion. But they use ball bearings instead of threads. Way less friction makes them more efficient, especially at high speeds. Like think dragging a box on a rough floor versus rolling it on wheels.
Gotcha. So each tool has its purpose. Acme for strength and safety, ball screws for speed. But back to Acme, it's all about their toughness, right? Like handling rough environments.
Yeah, they're known for being tough. You can take dust, debris, moisture, vibrations, things that kill other parts.
So what materials are they usually made of? Just basic steel or something fancier?
Oh, choosing the material, that's a whole science in itself. You've got different steels, each with pros and cons. Carbon steel, super strong, but rusts easy. Stainless, great against corrosion. Then there's aluminum, lighter, or even some plastics for certain jobs.
So it's like balancing strength, how long it'll last, and where it's going to be used.
Exactly. Engineers got to think about all that. But speaking of materials, this brings up a key point. Acme screws, super strong, but they're not the most efficient out there.
You mean because of the friction between the threads? Like we said with ball screws.
Exactly. Some energy is always lost to friction, and that can be a problem if you need top efficiency.
Right. Got to weigh the trade-offs. You get strength with Acme, but maybe lose a bit of efficiency.
Yep. No perfect solution in engineering. It's all about picking the right tool for the specific job.
This is so interesting. Never thought so much went into just a screw. But how do these different materials actually play out in real life? Are there jobs where one's clearly better?
For sure. Say you're on an oil rig, all that salt water. You'd want stainless steel for your Acme screws. But building a plane part, maybe aluminum's the way to go. Keep things light.
Makes sense. So the material depends on the job.
It really does. And sometimes you even combine materials, like a steel screw, but a bronze nut cuts down on wear and tear. Pretty neat, huh?
Wow, that's some serious engineering. Okay, I gotta ask, real-world examples now. Where are these Acme screws actually being used? Give us the behind-the-scenes scoop.
Okay, let's start with construction. Think about those giant cranes lifting those huge beams and stuff. Acme screws are often the muscle behind that lifting power.
Crazy to think a screw can do that. How does that even work?
It's that trapezoidal thread shape, turning rotational motion into linear motion, really effectively. Picture a giant hand slowly turning a massive nut, lifting that heavy load. That's an Acme screw in action.
Okay, so the crane's got a motor turning a huge Acme screw, and that lifts the beam. Am I getting it?
That's a great way to visualize it. And it's not just about brute strength either. Think about building a bridge. Those sections need to line up perfectly. Acme screws are often in the systems doing that.
Wow, holding a bridge together? That's a lot of responsibility for a screw.
Absolutely. They're holding things together in some seriously tough situations.
This is eye-opening. Okay, we've covered design, materials, even some real-world uses. But here's the thing. If Acme screws are so good for heavy duty, why aren't they used everywhere? Wouldn't they work for smaller projects too?
You're hitting on a key point. Engineers always got to pick the right tool, right? Acme's great for some things, not all. Sometimes you need something smaller, lighter. It's all about trade-offs.
Okay, so what are some times when Acme isn't the best choice? What are its downsides?
Well, we've talked efficiency, but they can also be a bit noisy compared to other systems. That's fine in a factory, but in a medical device. Or your phone, not so much.
Ah, good point. Noise matters. Anything else to watch out for?
Another thing is backlash. That's
Yeah.
like a tiny delay or wiggle in the movement. If you need super precise positioning or perfectly smooth motion, maybe not the best.
Got it. So not for super smooth or super accurate stuff. What would you use then?
Well, ball screws, like we said, they're good for that smooth, precise stuff. They're often in machine tools, robots, places needing real accuracy. And then there's linear actuators, basically a motor and motion system all in one. Super easy to use.
Wow, so many options. Okay, back to Acme though. If they have these downsides, why are they still so popular?
That's a good question. A big one is that self-locking ability we talked about makes them super safe, super reliable, especially where you really don't want any accidental movement.
Makes sense that self-locking is a huge plus for safety. Anything else that makes them stand out?
They're also just plain simple and tough. Not many moving parts, so they last a long time and can take a beating. Harsh environments, heavy loads, even getting knocked around. Perfect for industrial use.
So they're like the reliable truck of linear motion. Not fancy, but gets the job done.
Exactly. They're the ones you count on when things get tough.
Man, this is fascinating. Never realized how much is behind something as simple as a screw. But why should our listeners care? How does this apply to their lives?
Well, besides learning how stuff works, it opens up possibilities.
Yeah.
Once you see how these things work, you start seeing potential uses everywhere.
Like we could invent our own stuff using these ideas.
Exactly. Maybe you'll build furniture with super smooth adjustments or a DIY project using self-locking. Once you get the principles, the possibilities are endless.
I like that. Learning about a screw can actually spark new ideas.
It really can.
Yeah.
I gotta say, I'm seeing screws everywhere now. But think of all the machines on farms, tractors, harvesters, all that. Tons of them use Acme screws for adjusting things, lifting, even controlling how seeds and fertilizer come out.
Huh. Never would thought of that. They really are versatile.
That's good engineering for you. And speaking of versatile, let's talk energy. Acme screws are big in that too.
Energy, like power plants and stuff?
Yep. Wind turbines, solar panels, they all use them.
Okay, now you have to explain that one. How do screws fit into renewable energy?
Okay, picture a wind turbine, those giant blades way up high. To keep them facing the wind, the whole top part, the nacelle, has to rotate. And guess what often helps make that rotation happen?
Acme screws. Feeling pretty confident now.
Bingo. They've got the strength to turn that whole massive thing.
Wow, so they're helping harness the wind's power. That's pretty cool. You also said something about entertainment, though. Still drawing a blank on that one.
Think amusement parks, rides, stage sets, even movie special effects. They use Acme screws for all sorts of movement, lifting heavy props, even making those drops on roller coasters.
You're right. It's like they're behind the scenes of all the fun stuff.
Exactly. Shows how knowing a bit of engineering can make you see the world differently.
Totally. But let's get back to the screws themselves. Are there, like, different types of Acme screws? Or is it all one basic thing?
Good question. There are actually a few types, each good for different jobs. You've got your standard Acme threads, those are the most common. But then there's stub Acme threads, shorter and squatter, good where space is tight.
Right, tool for the job, like we were saying before.
Exactly. And there's even more specific ones, trapezoidal screws, metric Acme screws, whole world of them.
Wow, who knew there were so many screw options? So how do engineers pick the right one? Just size and strength.
There's more to it. The lead of the screw matters a lot. That's how far the nut moves with one turn. A fine lead is slower, more precise. A coarse lead is faster, but less force.
Another trade-off then, speed versus precision.
Yep, got to find that sweet spot. And you got to think about how much weight it can handle, how efficient the thread is, even what materials the nut and screw are made of.
Yeah, it's like a puzzle figuring all that out. We talked about different Acme screw types, their good and bad points, and even some other options.
We have. It's been a pretty comprehensive look at Acme screws and how they fit into the world.
Exactly.
But there's always more to learn, right? Especially in engineering, things are always changing.
True. Speaking of changing, we've talked about Acme screws now, but what about the future? Any big innovations coming down the line? Self-lubricating screws? Super materials?
Ooh, those are good ones. It really depends, though. The basic Acme idea is old, and it works. But there's always room to improve. Like materials, that's a huge area. Imagine a screw as strong as steel, but light as plastic. That'd be huge for planes, robots.
Sci-fi stuff. What about the screw's design itself? Anything new there, or is that pretty much fixed?
Well, that trapezoidal thread shape, that's been around forever. And it's good, but people are always tweaking it. Maybe new shapes that are more efficient, less wear and tear. We might even see like smart screws with sensors built in, telling you when they need maintenance.
Smart screws, the future's wild, but what's pushing these changes? Just better materials and designs.
It's more than that. Automation is a big one. More robots and stuff means more need for good linear motion.
Makes sense. If machines are doing more, they gotta be reliable. Anything else shaping the future of Acme screws?
Sustainability, too. Saving energy, less waste, that's becoming more important. So, new Acme screws might be more efficient, use less material, last longer.
So it's not just how well they work, but how they work in a bigger sense. What about those new fields like robots and green energy? Will Acme still be important there?
I think so, yeah. They're simple, reliable, and not too expensive. That matters. Robots need strong, precise that can work anywhere. Acme fits that. And green energy. You need stuff that lasts. Acme is good for adjusting solar panels, wind turbines.
So Acme's got a good future then. Not the flashiest, but it gets the job done.
Definitely. They're kind of the unsung heroes making our world work.
This has been awesome. I went from knowing nothing about Acme screws to being kind of impressed by them.
Glad to hear it. It's cool how something simple can be so complex when you look closer.
Okay, before we wrap up, any last thoughts for our listeners? Something to think about when they see an Acme screw out in the wild?
I'd say remember that engineering is everywhere, even in everyday things. Next time you see a crane, a factory machine, even a chair that adjusts, think about how it was designed. Maybe you'll get inspired to learn more, even invent something yourself.
Love that. Finding that curiosity, realizing that even simple things can be super interesting.
Exactly.
Well, that brings us to the end of our Acme Screw Deep Dive. Hope you enjoyed it and learned something new about these hidden parts of our world.
Thanks for listening, everyone. Keep exploring, keep learning. There's always something new to discover out there.